Good day. We're here to recap all of our reInvent storage announcements from back in 2018. My name is Yuriko Horvath. I'm a solutions architect with our worldwide public sector, AWS Federal Civilian team. Let's get started. I'm going to start off talking through some of the different migration patterns you as our federal customers have towards AWS. First of all, we have those who want to lift and shift your current infrastructures from your data center environments into AWS, and for that we call that rehosting or lift and shifting. In those cases, you might be taking advantage of course, our EC2 servers. So those are our compute servers, elastic compute, and then those would be attached to EBS volume. So that's our elastic block storage. Going around our circle here, we've got our replatforming. This is if you are lift and shifting, but you are modernizing towards the cloud in a componentized fashion. So this would be including our AWS Storage Gateway family. You would also be using EFS, our Elastic File Service, and being announced as a reInvent, and we'll be discussing it today, our FSX family of file servers, both for Lustre and for Windows. Going towards a re-architecting side, so this would be those applications who are being modernized and built directly to integrate with the cloud. We have our object store, S3, our simple storage service, and we will be discussing new announcements there as well. So we're going to start off on the full re-architecting side of modernization. So this is seeing the art of the possible. We'll start off there, and then we'll go towards rehosting and replatforming technologies as well. For the features that we've added as of reInvent around S3, we'll be talking about S3 intelligent tiering, and also we'll be talking about S3 batch operations. Let's review our different storage classes for S3. So on the left side of the slide that you see here, you'll see our S3 standard storage tier. This is for all of those objects that you are storing that you are accessing frequently. You've got less millisecond level of access. You have redundancy in over 3 different availability zones, and you're paying around 2 cents per gigabit per month. Then for those objects that you are accessing less frequently, we have other storage classes as we move right on the slide. So this includes S3 IA, so that's our infrequent access. These are for those objects that you are accessing less than once a month. You will be paying less for storage, but you will be paying an additional access fee for these objects. We also have S3 one zone infrequent access, so S3 one zone IA. And these are for objects that you want to store where you don't want to pay for as much redundancy, but you are also accessing it on a less frequent access point. And we have Glacier. So Glacier is for those archive use cases that you have, where you don't necessarily want millisecond level of access to these objects. Instead, you will be accessing these objects on a level of in a few minutes or in a few hours. That's when you want to be able to restore your objects and then gain access for your applications. And you have cost savings as you go towards the more infrequent side of access. So legacy-wise, when you wanted to move your objects from S3 standard all the way towards infrequent access or Glacier, traditionally you had to rely on lifecycle policies to store your objects in S3. And then let's say 180 days after you've stored your objects or whatever policy you set up, your objects are migrated from S3 standard into S3 infrequent access or Glacier. But this means that you have to know ahead of time your usage patterns around accessing your objects and relying on a sort of date-time frequency to move your objects between these different tiers. Now, with S3 intelligent tiering, you can have the automated cost savings where you are relying on Amazon to moderate the access patterns of your objects and automatically moving your objects between the different tiers from S3 to S3 infrequent access. So this is great for those large objects that you're storing where you don't know those usage patterns at all. We will be paying attention to those objects that are accessed less frequently, and then again, move them from S3 to S3 IA. You will be having cost savings for this, and you pay a per object fee to make these decisions for you. Now let's get into S3 batch operations. So traditionally, Any operations you were doing on your objects within S3, you were doing it per object. Now you have the ability to make a manifest file. This is a list of all the different S3 objects, and it can be into the thousands or millions of objects. You put it into a manifest file, and then you select an operation that you want to do against this whole list of S3 objects, and then you can view the progress of this being done. What are these different use cases that you might be thinking about? This includes replacing the tags on all the different objects within a bucket. This could be changing access control on objects from maybe public to private or vice versa. This could be restoring a whole list of objects with a certain prefix from Glacier into S3. This could be copying objects from one bucket to another. Or, and this is a new paradigm, the idea of running a Lambda function against a group of S3 objects and not only relying on that lifecycle side of things with S3. As an example, previously, you would do things along the lines of every time you put an object in a bucket, a Lambda function would run. Now, you can create that whole list of S3 objects that you want to run a Lambda against and then perform it that way. What are some other releases that we have around S3? We now have that concept of S3 object lock. This is for those write once, read many times, or your worm use cases. So this is protection on your S3 objects, which give added governance and retention controls in helping with your compliance scenarios. So every single time you write an object, you have that confidence that those objects are not going to be updated or deleted without you wanting to. In addition, we have S3 block public access. So this can be set up at an account level where buckets within that account will never accidentally be made public or be created in a public manner. So now with this sort of design pattern, we are encouraging you to have other AWS accounts that are primarily for those public use cases, and therefore inside your workload accounts where you don't want to have public access even accidentally on your S3 buckets, you now have that level of control. And for object tags, we know object tags, they've been around for a while. This is the idea that you can have up to 10 tags per object stored in S3. But now you can use these tags to indicate what sort of objects should be replicated or archived into Glacier or go through cross-region replication. So speaking of regions, we now have new additions to our cross-region replication. Now at the bucket, prefix, or object level, you can replicate your objects from one S3 bucket in one region to another region. So now you have the cost savings that you want and the level of controls that you want to only copy or replicate the data that you desire from one region to another. You can also use cross-region replication across all of our storage tiers. So this can be Glacier, this can be S3 IA and S3 now. Now let's talk through Glacier. This is for all of your archiving scenarios, and this is still on the modernization side object storage within AWS. Let's start off with previously. When you were putting objects into Glacier, you had to put them into S3 and then go through a lifecycle policy to transition your objects into Glacier. So let's say you wanted to directly archive certain objects. We were asking you previously to set up a lifecycle policy for 24 hours so that you had to store it in S3 and then it would be transitioned into Glacier. Now we have direct puts, so you can directly put your objects straight into Glacier. In addition, we have cross-region replication for Glacier, which I just talked about previously. And now let's look at our different restore features. We have now notifications, so when you start to restore a group of objects from Glacier, previously you'd have to go back and check to see if they had completed. Now we have notifications that fire off when objects have been restored from Glacier into S3. So now you can think about your applications and webhooks to hook onto these restores so you can start taking actions on those objects automatically. We also have those restore speed upgrades. So let's say you discover that your objects are being restored at a rate that wasn't quite satisfying to your applications. Now you can go through and while our objects are in progress restoring, you can upgrade from a level of hours to restore your data to now minutes on the fly. And in addition to announcing our S3 intelligent tiering, now we have S3 Glacier Deep Archive, our coldest storage yet. With Deep Archive, you are no longer needing to manage your tapes. So this is a replacement for your tape archive in your on-premise environment. But now you have the advantages of 11 nines of durability. So this is if you're storing 10,000 objects across 10 million years, you have the possibility to lose one of those objects. You also have the ability to recover your data within hours. So this isn't like Glacier where you can opt into minute type of recovery. You are looking at along the lines of 12 hours to recover your data, but you're getting all of this functionality for less than a quarter of the cost of Glacier. I was just doing cost estimates for one of my customers, and storing 1 petabyte worth of data in Glacier Deep Archive was looking like $1,000 per month, not including recovery. Now let's look towards those of your applications that are more going for the lift and shifting or the re-platform. So that's a lift and shift with slight modernizations towards the clouds. For this, we'll be looking at EBS, our Elastic Block Storage, EFS, our Elastic File Service, and also announcing FSX. Starting off with EBS. So EBS, it's been around for a while. This is basically think of it as your storage hard drives that are connecting to our EC2 compute servers. But we've been working on performance. Now we have 2 times the performance improvement for provision IOPS for our standard SSD volumes. In addition to that, we have a 60% improvement for our GP2 SSD volumes. And now we are introducing also EFS, infrequent access. So similarly to S3 infrequent access, now we have this for EFS as well. So you don't have to make any changes to your existing applications, but you can start to take advantage of cost savings for those files that are not accessed as frequently. What types of cost savings are we looking at here? This is for standard storage class for EFS. It's around 30 cents per gigabyte per month. And now we're looking at 4.5 cents per gigabyte per month with an additional fee for recovering your data, similar to how S3 infrequent access works. How does this work? Well, you create your file system, same as what you were doing with EFS previously, but you enable Lifecycle Management. And then for any files that are accessed less frequently than once a month, these are automatically moved to EFS IA for you. But when you do need to access those files, you don't have any degradation of performance. So we just discussed EFS, which is great for your Linux applications. Now, what about your Windows applications or your HPC applications? Well, now we are announcing Amazon FSX for Windows File Server for those Windows applications, and Amazon FSX for Lustre, and this will help you out for your HPC needs. Amazon FSX for Windows File Server. So this is previously you were managing this yourself. But now Amazon has a fully managed service for you, so you never have to worry about patching or upgrading your file servers again. And we're supporting back to Windows 2008. In terms of compatibility, we're looking at supporting NTFS, also SMB, Active Directory, and DFS. And for your HPC workloads, we have, again, FSX for Lustre. So this is the preferred parallel file system for our HPC customers that we've seen so far. But we're going to, again, manage this for you in a secure manner. So how does this work? When you're storing all your data for your HPC needs, this data will be loaded through FSX in a parallelized fashion. And then those can be used by your HPC cluster. Now, when your HPC cluster is done with all of its compute needs and it has results to store back in S3, again, it's going through FSX and in a parallelized fashion being stored back into S3. We're seeing greater than 100 gigabytes per second throughput, millions of IOPS per second, and consistent sub-millisecond latencies with FSX for Lustre. So we've talked about your modernized workloads, we've talked about what you're doing for your lift and shift workloads, but at some point you need to migrate or transfer your data into S3 or other storage options. And for that, let's look at our options there. First of all, what are some of these use cases for active migration of your data? First of all, this is for those applications where you are running on-prem. These are still live applications. They're still saving data, but you want to start replicating this data and migrating it into AWS. For those active environments, you need a solution for this. You also have transfers in a timely manner. Sometimes you don't have the option of having an outage for multiple different days while your data is being transported, and you want to do your transfer in a timely manner. We need to look at options for that as well. Or this is ongoing replication for data recovery needs. For all of your active application migration needs, we have AWS DataSync. How does this work? Well, you start off by deploying an on-premise agent to your workloads. Then either over direct connect or over the WAN, you are in an encrypted fashion transferring your data over to the AWS environment. From there, AWS DataSync takes control and saves your data into S3 or into EFS. Past AWS DataSync, we also have, for your applications who are currently utilizing SFTP clients, we have a solution which is AWS Transfer for SFTP. So with this, you can now store your data into S3 without having to do any sort of modernization of your applications who are already using these clients. And Snowball. So this is when you have your multi-terabyte, multi-petabytes worth of data that you need to move into AWS, and you can't do this necessarily over direct connect or the internet efficiently. In that case, we have our ruggedized hard drive devices called Snowball. But Snowball as storage wasn't enough. We've noticed that our customers have wanted to do some level of compute on top of their storage. So we have Snowball Edge Storage Optimized. So this is the idea: you still have 100 terabytes worth of object storage, but you have 24 vCPUs on top of this and 32 gigabytes of memory. So you can do some level of compute on all of the objects that you're storing at any point in time. But now we are also announcing, as of reInvent, our Snowball Edge Compute Optimized, which have 42 terabytes worth of object storage, 52 virtual CPUs, and 208 gigabytes of memory. And with that, we are concluding all of our announcements around Amazon's products and services surrounding storage. With that, go talk to your account managers and your solutions architects so we can help you architect forward with these new announcements.